In this part of the series, we'll be looking at the atmospheric conditions which give rise to the weather, as well as its causes, changes, and effects. While time restricts our discussion to a general overview, hopefully you will gain sufficient insight to be able to foretell conditions and govern the course of your trip accordingly. It's important you have a working knowledge of what causes changes and the effects these changes can have. They will have a direct bearing on whether you continue travel or establish camp, whether your campsite is exposed or sheltered, the clothing you wear, and the food you consume. Normally, we rely on media weather predictions. These are compiled from a number of sources covering a wide area. Despite the latest advances in technology, however, they can prove inaccurate. In the wilderness, your concern is the immediate area of travel. Furthermore, you normally don't have access to media forecasts. Here you must rely on the signs of nature. Learned through time and experience, they often prove accurate. That's why seasoned wilderness travelers such as guides and bush pilots are frequently correct in predicting forthcoming weather. They determine it from the sky and their natural surroundings. Nature's signs take many forms. The sky itself is one of the best. It has been the subject of much study through the ages. For instance, the old adage, "Red sky at night, sailors delight. Red sky in morning, sailors take warning." Taken from a passage in the Bible, it has been handed down from generation to generation. It foretells good weather when the sky is red at sunset and bad weather when it is red at sunrise. The rapid movement of clouds or the buildup of heavy dark bases are signs of changing conditions. We can also look at our surroundings. Upturned leaves of deciduous trees normally precede rain. The irregular movement of birds and animals warn of deteriorating conditions. By observing the sky and your surroundings, you will become familiar with certain indicators. These will assist in your predictions. All weather conditions develop in the atmosphere. This is an envelope of invisible gases surrounding the Earth. Closest to the Earth's surface, it contains various concentrations of water vapor. The form of this vapor changes under differing pressure and temperature conditions. The pressure of the atmosphere decreases as a parcel of air rises from the Earth's surface and increases as it descends. As air rises, the decreasing pressure allows it to expand. This is accompanied by a reduction in temperature. The resultant cooling process causes the water vapor to condense and form clouds. Thus, cloudy skies are associated with rising parcels of air. When a parcel of air descends, its volume decreases. As the pressure increases, the temperature rises. This causes any moisture to evaporate, with the result, a clear sky is normally associated with descending air parcels. It helps to remember that as cooler air is denser than warm air will rise. As it rises, it reaches regions of lower pressure, expands, and cools. This results in condensation and the formation of clouds. When a parcel of rising warm air is saturated with water vapor, or the rise is too rapid, the excess water is released in the form of rain. Parcels of air are classified as being either stable or unstable. A parcel of unstable air will continue to rise after its initial upward thrust, while a parcel of stable air will fan out and remain constant. With unstable conditions, there are strong upward vertical currents. Clouds are generally of the heap variety. Visibility is good as the upward currents carry impurities aloft. If there is rain, it is generally intermittent in the form of showers or downpours. Under stable conditions, clouds will be of the layer type, and there will be fog. As impurities in the air are not carried upwards, visibility is more restricted. When rain occurs, it is normally uniform in the form of drizzle. As a rule, therefore, travel conditions are more favorable with stable air conditions. Weather forecasts frequently refer to areas of high and low pressure. These are shown by isobars, which are lines of equal atmospheric pressure. On a weather map, they look like whirlpools. An area of low pressure is a depression which extends out from the center by means of a trough. The lowest pressure is at the center point. Its width can vary from less than a mile to many hundreds of miles. In the latter case, it is commonly referred to as a large depression. A low develops when warm air rises. If it contains a lot of moisture, rain will occur as it cools. Air pressure is measured by a barometer. When the needle falls, it means there is less air pressure and a low is approaching. A high-pressure area extends in the form of a ridge, again with the highest pressure at its center point. When approaching, the barometer needle will rise. High pressure is usually associated with dry air. A low usually brings clouds and rain. High winds can be expected. Fair weather is normally associated with a high-pressure area. As stated earlier, the temperature of the air has a direct bearing on the weather. The air is heated from below by the Earth. The Earth's source of heat is radiation from the sun. The Earth's surface acts as a radiator. It retains some of the heat and transmits the remainder back into the atmosphere. Clouds have a definite effect on ground temperature. That's why it's usually cooler on a cloudy day than a clear one. Cloud layer acts as a mirror, reflecting the sun's radiation back into the atmosphere. At night, it is warmer under a cloud cover than clear sky. While the Earth releases its retained heat into the atmosphere, the clouds radiate this heat back to the Earth. When setting up camp for the night, be prepared for a more extreme temperature drop when the sky is clear. Wind is defined as air in motion over the Earth's surface. Caused by changes in temperature, it is identified by the direction from which it is moving. A north wind blows from the north. While in the wilderness, wind will have a direct effect on your speed of travel and living comfort. In warmer weather, it can be of benefit dispersing insects and providing a cooling effect. In cooler weather, it can chill you and cause body heat loss. This occurs when the temperature of the air is cooler than the skin, and the skin is exposed or inadequately covered. Called the wind chill factor, the speed of the wind determines the degree of heat loss. As wind chill can cause hypothermia, in cooler temperatures, gauge your clothing requirements by the standing temperature and force of the wind. Having covered some of the underlying factors which determine weather patterns, let's turn to the various cloud formations. They are important in determining weather conditions. But before doing so, let's review what we have covered. Through time and experience, you can learn to predict the weather from the sky and your natural surroundings. Weather conditions develop in the atmosphere. Atmospheric pressure decreases as a parcel of air rises. It expands and cools with the result you normally have cloudy skies. When a parcel of air descends, the pressure increases, its volume decreases, and the temperature rises. This causes moisture to evaporate, resulting in clear sky. Parcels of air can be either stable or unstable. When unstable, there is strong upward movement. Visibility is good, and clouds are of the heap variety. If there is rain, it will be in the form of intermittent showers or downpours. When stable, clouds are of the layer type, and rain is usually uniform in the form of drizzle. Areas of high and low pressure are shown on a weather map by isobars. A low is usually accompanied by clouds and rain, while a high is associated with clear sky. Temperature has a direct bearing on the weather. It is cooler on a cloudy day and a clear night. And finally, wind has a direct effect on travel speed and comfort. It provides a cooling effect when it is hot and a chilling effect when it is cold. Now let's turn to clouds. With a uniform base and no markings, they are of the stratus class. Those without a base and form structure are of the cumulus class. When the main component is moisture, they belong to the nimbus class. There are four main groupings. The first is high clouds, normally more than 20,000 feet above the Earth's surface. Here the temperature is far below the freezing point. Frequently composed of ice crystals, sometimes water droplets, referred to as supercooled water, can exist. It includes cirrus, delicate silky white thread-like or fibrous ribbons frequently occurring in tufted formations called mare's tails. Cirrus stratus, a thin whitish veil extending over most of the sky. And cirrocumulus, small rounded masses or white flakes with little or no shadow. They quite often form in lines. These normally exist under stable air conditions and don't foretell rain. If, however, cirrus or cirrostratus clouds thicken and appear to be moving lower in the sky, be prepared for rain. Quite often, this is caused by an approaching warm front. The second grouping, known as middle clouds, is normally located between the 6,500 and 20,000 foot level. They can be composed of either ice crystals or water droplets. Here you'll find altostratus, a fibrous gray veil faintly illuminated by the sun. Nimbo Stratus, a thick dark gray layer. And altocumulus, a continual layer of flat globules, long rolls, or waves. Quite often they are interspersed with blue sky. Altostratus and nimbostratus clouds can bring a lot of rain, which quite often lasts a full day. When altocumulus clouds are accompanied by rain, the amount is normally intermittent and small. The third grouping is designated as low. Usually located between the ground and 1,500 feet, clouds are composed of water droplets. This includes stratus, a low uniform layer which becomes fog at ground level. When rain occurs, it is usually light drizzle. If they appear in the morning under calm weather conditions, you can usually be assured they will evaporate with the heat of the sun. Stratocumulus, a low-lying gray layer which can be either thick or thin, quite often with a lumpy or rolled appearance. These clouds are normally associated with light intermittent drizzle. If they appear in the morning, accompanied by strong winds, be prepared for a cloudy day. Lastly, there is the vertical grouping. These clouds rise from 1,500 feet above ground level and are composed of either ice crystals or water droplets. Here we have cumulus, dense heaped up masses with flat bases and rounded tops. They have a tendency to form during the day and disappear at night, being either white when exposed to the sun or dark with overcast conditions. Be forewarned when cumulus form into cumulonimbus clouds on a hot, humid day. Even though the sun may shine between them, active thunderstorms are coming. And finally, cumulonimbus clouds. These are heavy masses with dark bases and tower-like tops, often spread out. The contours are constantly changing due to the abrupt upward movement of air currents. These foretell thunderstorms which can be accompanied by hail or gusts of wind. When approaching from the northwest, expect cooler air followed by clear skies. Forecasters often refer to warm or cold air masses. These are bodies of air with uniform temperature and moisture characteristics. They are separated by relatively narrow transition zones called fronts. An air mass can cover a large portion of the North American continent. It should be distinguished from a pressure system, as one or more air masses can contribute to it. The movement and interaction of these masses and their stability or instability has a direct effect on the weather. There are three main components of developing weather conditions. They are the moisture content, the operative cooling process, and the stability or instability of the air mass. In most cases, when air is heated from below, it will become unstable, while if cooled from below, it will become stable.